Welcome to this bonus lesson on interpreting survey results. A lot of companies are putting out surveys, and when you work in people analytics you might be in the same position that you have to put out a survey. Now, between getting the results of the survey and doing the actual analysis, there are a few steps you should take in order to get accurate data. And these are the 5 steps that you should take when interpreting your survey results. I'll talk you through them one by one, and I'll refer you to additional material where you can learn more about these. Now, first of all, you need to make an initial scan of your data. Second, you want to check for bias in response rates. Third, you want to measure internal consistency of the skills that you put out. Fourth, you want to check for outliers, and we've spoken about this already. And 5, you want to measure skill factors. I'll go over each of these steps one by one, but first let's go over some definitions that you need to know in order to do this right. The first one is the Likert scale. The Likert scale is a psychometric scale that's commonly used in surveys. In a Likert scale, survey respondents simply don't choose between yes or no, but there are specific choices based on agreeing or disagreeing on a certain question in the survey. An example of a 5-point Likert scale is very unsatisfied, unsatisfied, neutral, satisfied, and very satisfied. The 5-point is the most often used Likert scale, together with the 7-point Likert scale. Shorter versions are also available, each of them have their own advantage and their drawbacks, but my recommendation is to go for the 5-point Likert scale as a standard, unless there's a good reason to choose otherwise. Now, second are constructs. A skill usually measures a construct. A construct is an explanatory variable which is not directly observable. An example is engagement. Engagement cannot be observed, so we measure it using a skill. Based on the answers to a set of predefined questions, we can measure the construct, even though we cannot directly observe it. Third, dimensions. Dimensions are the classification of a construct. If we take, for example, the construct of engagement, the most common definition is: engagement is a positive, fulfilling, work-related state of mind that is characterized by vigor, dedication, and absorption. This definition mentions 3 dimensions: vigor, dedication, and absorption. By measuring all 3 dimensions, you measure the construct. In the most commonly used scientific scale for engagement, there are 9 questions, 3 per construct. An item. An item is a single question on a survey. Now, these are terms that I'll refer to for multiple times for the rest of this lesson. Let's go to the 5 data processing steps that we just spoke about. First of all, you need to familiarize yourself with the data. The easiest way to do this is by looking through the data and comparing it to the questions you asked. The first step is usually to identify the questions that are asked as an opposite of the construct you're measuring. Take, for example, the following item. I often feel I lack energy when I'm at work. This is a negatively framed question that inquires about someone's energy level, which is one of the dimensions of work engagement. In this case, because you're trying to measure vigor, you want to recode this question, changing the lowest input to the highest and the other way around. This is an example of a 5-point Likert scale question that's recoded using SPSS. A 1 becomes a 5 becomes a 1, etc. In this step you can also create a frequency table to analyze your data. Such an analysis helps you to identify the highest and the lowest value, the mean, the mode, and other descriptive statistics. The second step is check for bias in response rate. When you set out an engagement or any other kind of survey, you want everyone to be represented equally. In this step, you can check the response rate for different groups in the organization. You may want to check whether key criteria like function group, full-time equivalent, tenure, and job types are all equally represented in the study. This can be done through a chi-square statistic. A chi-square statistic is used to investigate whether distributions of categorical variables differ from one another. I will include a document with the specifics of this test in the reading material. The take-home message is that this test is an easy way to check for equal response rates. The third step is measuring the internal consistency of a skill. This is done through Cronbach's alpha. Cronbach's alpha is the measure of the reliability of a scale. For example, you have a skill that measures someone's vigor using 5 questions. 4 out of 5 questions tend to score high for some and low for others. However, the 5th question behaves as a polar opposite. In this case, the internal consistency will be low because of this last question. This could be caused by a wrongly worded question, a question that measures something else, or it could be a negatively asked question that you forgot to recode. Removing this question from your survey will offer a much more consistent skill. On the slide you see an SPSS output of a skill that measures innovation with a very high reliability. That is the advantage of working with a pre-tested skill. Removing one item will only lower Cronbach's alpha, so that's not advisable. We can leave the skill as it is. Removal of an item should only be done when the item is logically inconsistent with the rest of the skill. This means that you should not remove the item because it will increase your Cronbach's alpha, but because the item doesn't fit with what you're trying to survey. Cronbach's alpha is therefore just an indicator for errors in your questionnaire that will help in improving your skill for future use. There are a number of guidelines for using Cronbach's alpha. The following table shows an excellent rule of thumb. Depending on the severity of the consequences of a survey score, a different criterion will be used. For example, for diagnostic criteria, you will want to have an excellent internal consistency, while for general work-related information that will not be used to make life-altering decisions, an alpha upward of 0.7 is acceptable. Everything below 0.7 should be improved. The 4th step is the outlier check, and we've already spoken about outliers in the first module, but this is the place to do it. Using the interquartile range, you can calculate a minimum and a maximum value for your data and flag the individuals that fall outside of this range. These are values that you can relatively safely remove from your dataset. If you happen to know these people, and this is a tip that you haven't heard before, a qualitative interview with them might be very interesting just to learn more about their experiences and why they scored so high or so low. The outliers are usually the ones who are best able to express their thought about a topic because they think or they care about it so strongly. The 5th step is an analysis of the skill factors. A factor analysis is a complicated analysis in which the values of the observed data are expressed as a function of a number of possible causes in order to find which ones are the most important. The maximum number of factors always equals the number of questionnaire items. However, if a single factor fits the data very well, this is a sign that the skill isn't merely a sum of individual questions, but that there's a single underlying concept. The factor analysis is a way to cluster data into different groups. It is a complicated analysis that I would only advise to use when you're actively involved in developing a new questionnaire or validating an old one. Because the factor analysis enables you to identify one or more factors in a survey, in an ideal world, these factors represent the thing you're measuring. If you're measuring engagement using the 3 dimensions that we mentioned earlier, vigor, absorption, and dedication, you will want to see either 3 distinct factors in your factor analysis or one single factor, which is engagement. If you see 2 or 4 distinct factors, that could be an indication of a measurement error. In addition, if you do see 3 separate factors, you want the questions that measure those different dimensions to score on those different factors. So the questions about vigor score high on factor 1, the questions on dedication score high on factor 2, and the questions on absorption score high on factor 3. So this is a good way to validate your skill. In the example you see on the slide, I analyzed the innovation skill that we looked at for our Cronbach's alpha previously. It shows that there's one component that explains almost 70% of the variance and 8 other components that explain very little variance. Based on the scree plot I showed in the previous slide and the table on this one, I can safely conclude that a one-factor approach seems to work well for this construct. In addition, I can see per questionnaire item how they score on this one dimension. If there would be one item with a very low score, this would again be a cause for additional analysis, and I would go back to the question and find out why it scores so low. There's more detailed reading material on the factor analysis in the reading material. Another term that I haven't mentioned yet, but that is important, is common method variance. This is another advanced topic that refers to the variance that is attributable to the measurement method rather than the constructs the measures are assumed to represent. For example, if I would ask a random group of people if they are good drivers, 90%, and especially men, will answer they are above average drivers. This is an example of common method variance. The variance is most likely explained by the way I measure the construct and not by the real value of the outcome. A better way to measure it would be to give a driving test. A good way to cope with this is to measure the same thing using different methods of measurement. I can always ask employees how innovative they are, but I can also ask their managers in how many innovation projects an employee has been involved and how active that involvement is. If both measures overlap or correlate, that would be an indication of a true score. This brings us to the end of this bonus lesson, in which you've learned a step-by-step approach to cleaning and interpreting survey data. There's a lot more to it than I can capture in just one lesson. So, just like any other thing in statistics, read about it. Make sure you understand the core concepts and the details, and then make a choice that's in line with what you try to achieve in your research, in the most objective way possible. In the next bonus lesson, I'll dive into the analytics using a dataset. Enjoy the rest of the lessons, and I'll see you there.